So in this video of differentiation 5, we've been going through what is meant by increasing and decreasing functions. So we'll go through questions that involve you to find values in which the function is increasing or decreasing, and also go through how to prove that a function is always increasing or always decreasing. Now, a common question that might get asked for you with regards to differentiation is being asked to find the ranges of where the function is increasing and decreasing. Now, although these words haven't been used before, what it's basically talking about is finding the ranges where the gradient is positive and negative. So if the gradient is positive, it's increasing, and if the gradient is negative, it is decreasing. So how this relates to the previous work that we've done so far is if I just get my different colour pen, let's go for blue, and just make the screen a little bit bigger. So as you can see, we've got a stationary point at this point here, and we've got a stationary point at this point here. So if I just label this point A and this point B, and draw a sort of dashed line going through these sections here, and also just for argument's sake, let's say that this has got x value of minus, let's go for 3.5. and this has got a x value of, let's go for 0.7, let's say. So obviously this is, we could write this as a fraction as minus 7 over 2, or we could write this as x equals 7 over 10. And again, if you're not sure how we find the stationary points, then watch the previous video on just that. Now, looking at this particular part here, now on the left hand side of A, so where x is less than 7 over 2, minus 7 over 2, so this region here, now if I just mark all the places where it's got a positive gradient, so in this range here we've got a positive gradient, and in this region here we've got a positive gradient. So where this is increasing, so it's increasing in the ranges of where x is less than 7 over 2, minus 7 over 2 rather. And again, note how I'm not putting an equals, a less or equal sign is there, because when x is equal to minus 7 over 2, it's going to have a gradient of 0, and it's increasing when x is greater than 7 over 10. Now let's just make that a little bit neater. And when we're looking at decreasing values, so there, if I get a different colour highlighter, let's go for green. So in this region here, it's decreasing, so then we can say that it's decreasing. Now because this is just a continued range, now it doesn't make a difference the fact that it's dropping below the x-axis, so decreasing rather than decreases. So it's decreasing within the range of, and we go for the smallest value, which is minus 7 over 2 and 7 over 10. So this would be our answer for this particular question. So a question might ask you just on one of them, another question might ask you for both of them, so it's worth understanding what each of the sections are. So this is when the yellow is when it's increasing because we've got a positive gradient. And here also, so here we've got a increasing and it's a positive gradient. And in the green section, let's go for a green pen. Here we've got a, let's put it a little bit thicker. So here what we've got is it's decreasing as we have a negative gradient. So when you're asked to find the ranges of this, it's really important that you first establish what those stationary points are, because at those x values of the stationary points will give you what your upper and lower bounds are going to be for your increasing, decreasing ranges. So let's have a look at a few examples of finding the ranges of where the graph is got increasing or decreasing. So in this particular example, we've been asked to determine the ranges of values of x for which f of x equals 2x cubed minus 21x squared plus 36x minus 5 is increasing or decreasing. Now, to answer these types of questions, there's several steps in which you need to be able to do, and that's one of the reasons why these types of questions carry a lot of marks. So what I'm going to do is I'm just going to write on the side what these steps are. So the first thing we want to do is find dy over dx. The second step is what we then need to do is find the stationary points. So then we need to make dy over dx equal to 0. We then need to solve, find the x ordinates of the stationary points and then what we then need to do is determine the nature. So determine their nature, and then once we do that, I would say, although it's quite optional, is to sketch, and then step 4 is then state the ranges. So, like I said, now feel free to skip some of these stages when you are actually working through some of the questions that you may be attempting on this particular topic, but generally speaking, that's usually the 6 things we need to do. So let's have a look at applying this to this particular question. Now, the nice thing about this particular question is that there's no fractions or square roots, so I don't need to worry about having to rewrite the original function, so I can go straight into differentiating it. So what we've got is we've got 6x squared minus 42x plus 36. I then want to go on and solve that, so I've got 6x squared minus 42x plus 36 equals 0. Now from this I can go straight into the quadratic formula, or I can attempt factorising, or I can notice that each of the coefficients and constants are all factors, multiples of 6, so I can divide everything by 6, and which I get, no, bear with me because it seems to be lagging a bit, that there. So factorising it, I get x minus 1, x minus 6, which gives my x ordinates of my stationary point at 1 and 6. So these are the x ords of the stationary points. So the next thing I need to do is to determine the nature of those. Now again, at this point, I know it's a cubic graph. I know it's going to look something that looks like that. So it's clear to me that from my knowledge of cubic graphs is that when x equals 1, that's going to be a maximum. When x equals 6, it's going to be a minimum. But again, make sure you're taking your time and having a look at how many marks are offered, because in some cases you will get marks for this, and particularly when equations look a little bit more complicated, it might not be easy for you to determine which one's going to be which. So just going through the motions, we've got our second derivative formula is where we're going to be differentiating this here, and I've just noticed I should not be using dy dx. Instead, what we should be doing is using f dash dash of x, and again I'm going to be differentiating this, the top line, so we get 12x minus 42. So substituting when x equals 1, I get that that's going to equal 12 minus 42, which equals minus 30, and as we've said, that's going to produce a maximum stationary point. When I substitute f of 6 into my second derivative, I'm going to get 12 times 6, which is 48, minus 42, which leaves me with 6, which therefore is going to be a minimum. Now, as I mentioned in the last video, it's worth just stating that as, I don't know why, keep writing dy dx, so as f double dash x is less than 0, it's a maximum. And here what I should have written is as f dash dash of x is greater than 0, therefore it's a minimum. So it's just really good practice if you get into the practice of that. But again, like I said, when you kind of know what you're doing and you're in a rush to try and get these questions done as quickly as possible, you can sometimes forget that you can get marks for stating just those things. So going back to finishing off working out this answer here. So if I just do a sketch now, I'm just dealing with this side of the set of axes where I've got y and I've got x. Now you get absolutely 0 marks for your graph, so you don't need to worry about that. And so all I'm looking for, and if I just draw a dashed line at 1 and 6, and now what I'm going to do is just draw my curve. Now as long as it peaks and troughs at those particular points, that's all that matters. So if I go for 2 colours, it's going to work. Yeah, there we go. So let's go for light green. So for where it's increasing, that's this part here and this part here. So I can say that it's increasing when x is less than 1. And again, making sure you're not writing equals, because when x equals 1, it's the gradient is 0 and is a stationary point, or when x is greater than 6. And then for that central part of the graph, we've got, let's go for pink, which is here, and that pink section there represents where the gradient is negative, and that's where it is decreasing. So it's decreasing when x is between 1 and 6. And that there gives us our final answer. So just by following those kind of 6 steps, kind of one, make sure that we maximize any loose marks that we may get, and if your question is worth 6 marks, then there you go. Sometimes the question might ask you to sketch the graph, and it might not say in terms of the intercepts. They're not really bothered about the intercepts, because if it was, then we'd have to solve the polynomial, which is not, again, that's another topic, but again, it'll then turn this question into potentially a 10-mark question. So you might get this in a textbook where you're asked to sketch it as well, but in exam, that's pretty much all you'd be expected to do. So in our next example here, what we've been asked to do is determine the range of values of x for which f of x equals x to the power 4 minus 8x squared minus 3 is increasing or decreasing. So the first train of thought is we've got to find the stationary points. So again, looking at the equation, we've got no fractions, we've got no square roots, so I can go straight into differentiating f of x. So f dash of x in this case is going to be 4x cubed minus 16x. Then to find the stationary point, the gradient's got to be equal to 0, so let's make it equal to 0. Now at this stage, what you don't want to do is take things over to the other side and start cancelling, and one of the reasons why you don't do that is because you potentially lose certain values. So in this particular value, there could be more than 2, it could be more than 1 stationary point, we're not too sure, and I don't really want to go into sketching the graph just yet for us to decide to make sure that we've got it all, but I will show you what the graph of this does look like. So from this, what we now need to do is, as you can see, we've got 2 terms. Our coefficients of both x cubed and x, and we've got a factor of 4 that goes into, and also we've got x in each term. So if I take 4x out, I end up with x squared minus 4 equals 0. Now one thing hopefully you would notice from what I have in the brackets is that this here is a difference of 2 squares. So I can expand on this by writing x. And how I usually do this is what you have to square to get x squared, 4x, and what do you have to square to get 4? 2, 1's a plus, 1's a minus, and let's bring that 4x back in, equals 0. So solving this, we've got 3 values. So where 4x equals 0, x is going to equal 0. For x plus 2 to equal 0, we've got x minus 2. Let's put that there. And for x minus 2 to equal 0, I've got x equals positive 2. So I've got 3 stationary points that I need to be aware of. So from this, what I then need to do is work out my second derivative, so f dash dash x, which in this case, and again if I look at, this is my f dash of x, so differentiating this is going to give me 12x, let's get that pink pen back, so it's going to be 12x squared minus 16. So when I substitute f dash dash of 0, then that's going to equal minus 16, which is therefore going to be a maximum. When I substitute minus 2, now probably what would be better if you do this in numerical order, I'm doing it in the order which I've calculated it, but in hindsight it might find it easier, particularly for me to sketch, that if I substitute these numbers in numerical order. So minus 2 is going to be 48 minus 16, which is 32, which is therefore going to be a minimum, and f dash dash of 2 is also going to be 48 minus 16, which equals 32, which is also going to be a minimum. So what this graph is going to look like between those two values, so let's now have a look at what it's going to be. So if I mark this as minus 2, this is 0, and this as positive 2. So at minus 2 it's a minimum, at 0 it's going to be a maximum. Now I'm not too bothered about whereabouts this is on the y-axis in terms of both these values, this is just to help me work this out. And at positive 2 it's also a minimum. So what this graph is going to look like, it could potentially look something like a W. So from this W I've got my inception points. Now again, it's not really drawn correctly, let me just tweak that so that it is. Let's start again. So at this point here we're looking at minus 2. At this point here we're looking at 0, and at this point here we're looking at positive 2. So from this, what we then want to do is now work out what our ranges are going to be. So as I said, if you've got a range of colours or you've got some highlighters, let's look at where it's increasing. So it's increasing within this range here, and it's increasing within this region here. So what I can then go on and say is that with regards to this function, it's increasing when x is between minus 2 and 0, and it's also increasing when x is greater than 2. Now where it's decreasing, so let's get a different marker here. So it's decreasing in this region here and that region there. So from this, what we can then say is that it is decreasing within the range of where x is less than minus 2 and when x is between 0 and 2. And there is your final answer. Now again, if you've got access to a graphic calculator, this is where sometimes the shape of the graph can also help. You can actually go straight into just typing in the equation, and you can then solve it that way. However, you won't get your marks for using your graphic calculator, but it certainly will help you with regards to checking your right answer. So you can check for any mistakes. So and let's just label this as f of x equals y. So in this last example, we've been asked to prove that f of x equals x cubed minus 3x squared plus 3x plus 8 is an increasing function for all values of x. Now, these types of questions always tend to catch a few students out simply because of the wording. Now, if you take it into basics, what does the increasing function actually mean? Well, basically, what this means is that you want to show that the gradient is always positive. So if a question asked you, prove that a function is a decreasing function at all values of x, you want to show that the gradient is always negative. Now, at its face value, let's have a look at what this is. Now, first thing we want to do is find the potential stationary points, and there certainly will be with this. So again, I'm checking to make sure there's no fractions or no roots in there, so I can go straight into working out what f dash of x is going to be. So here I've got 3x squared minus 6x plus 3. And again, I want to make this equal to 0. And as you can see, I've got factors of 3. So I can divide everything by 3. So I've got x squared minus 2x plus 1 equals 0. So then what I've got is x minus 1, x minus 1 equals 0. So the only value I've got here is x equals 1. Now, if you're watching the previous example, one of the reasons why when we factorised and we went on to solve this is, for this I was trying to find the solutions. Here, I can do this because I'm actually making it equal to 0. So even if I did take a 3 out, for example, if I kept that 3 and wrote it like this here, then the 3 is not going to be a problem. Because I've got the positive 3 hasn't got an x, that's where it becomes complicated. What you don't want to be doing is cancelling things with x's. Taking out common factors, not a problem. But even if I did leave that 3, as you can see, it makes no impact to the final answer, because although I've got 3 sort of variables, 3 things being multiplied, the 3 can't equal 0, and that's what we're looking for. So the only thing that can equal 0 is the thing in the bracket. So from this, we can see that in this particular equation, we've only got one stationary point, which in hindsight actually makes a bit of sense. Because if you, I don't know what I'm doing there, if you imagine a cubic graph, is that cubic graph can either look like this, it can look like this, or it can look like that, or it can look like that. So with a cubic, you can actually have a point of inflection, which kind of implies that as x cubed is positive, it's going to look like this shape here. But the only way we can prove that is by therefore moving on to doing the second derivative. So now we know that this is the only stationary point. So let's just write only stat point. So working out the second derivative of x, so again, where I'm getting the second derivative is from here. What colour pen are we going for? There we are. And so doing the second derivative, we get move the 2 to the front, so we get 6x minus 6. And when I then substitute the x ordinate of the stationary point into this, we get 6 times 0 minus, sorry, 6 times 1. So doing that, getting a bit crazy. 6 times 1, take away 6, which leaves me with 0. So therefore, it's a point of inflection. And again, from this, as it's got a point of inflection and we've got positive x cubed, and we can go from either side. Another alternative you could do, if you're not too sure that we've answered the question carefully, is as we've got a stationary point at 1, you can show that the gradient on either side of 1, so if you think about using the table method, and we've got dy over dx, and we've got x, and then we've got the shape. So here it's going to be positive, it's going to be greater than 0, that's when it's 0, that's when it's greater than 0. So then it's going to look like this. So as you can see, for all values of x, it's going to be an increasing function. Although it's 0 at one point, it's not going down, which is what they're looking for. So therefore, it is an increasing function for all values of x. And there you go. So like I said, if you have any other further questions on this particular part of differentiation, or you would like a worksheet with a range of questions very similar to what we've gone through, feel free to drop me an email at 162maths@gmail.com.